we're going to begin our flashback talking about quadratic equations by looking at the different methods that you can use to figure out the roots or the answers that satisfy each of them. So one method that you've more than likely learned before is called the factorization method. So the way the factorization method works is that you look for two factors that are going to multiply to make each side. Well, we like 0 on one side, that's just 0. 0 times 0, we leave that alone. And then we look at this side, figure out two factors that are going to multiply to make x squared minus 3x plus 2. So we start off with any quadratic equation by making like kind of dummy brackets, was what I call it, or parentheses. So we start off by making something that looks like this, and that's going to equal the other side. Now, the first term, the x squared, that is going to come about from the multiplication of these two terms here. So sometimes this can be tricky if it's not just x squared, or if it becomes 2x squared or 3x squared. But with just a regular x squared, we know that this is going to be x and x, because x times x makes x squared. Now the tricky part to the factorization method is trying to figure out how to create these second terms, because the way that this is going to work is that this x is going to multiply by this number, this x is going to multiply by this number, and those together are going to create this. So we need to kind of think of this like cross it around. We're going to make negative 3x. Now, the one thing we do know is that these two numbers, here and here, are going to multiply to make positive 2. So what numbers multiply to make positive 2 that add to make negative 3? That's our challenge for this. And so two numbers that multiply to make positive 2 and add to make negative 3 are going to be negative 2 and negative 1. So we've, in a sense, factored this. Now the beauty part, once you're to this point, you can realize that well, any two numbers that multiply to make 0, okay, one of them has to be 0, right? There's no other way for that to work. So the only way that this equation can work is if x minus 2 equals 0, or if x minus 1 equals 0. And so if I know that x minus 2 equals 0, that is going to mean that x equals 2. And if x minus 1 equals 0, we know that x can equal 1. So these are our answers from this. So we figured out the answers by factoring. So it's a clever way to do this. However, it does not always work. You kind of need clean numbers generally that work together very well. But hopefully over time you'll notice that this is a very fast method, but it doesn't always work. Now, let's look at some other methods that may work in different situations. So the next one is completing the square. Now this is thinking about factoring in a little bit more advanced way. So what we're looking to do is create a square. So squares have two sides that are the same. Okay, so we're going to break this into 4 parts. Now, as you notice from the other example, we actually had kind of 4 different numbers. We had, when we factored our answer out. So what we have to do is figure out how do these 4 numbers make this. Now this is where we have to kind of manipulate. So what we're going to do is we're going to disregard this negative 7 right now. Okay, so what we're going to do is we're going to move it over. I'm going to call this x squared minus 4x, and then I'm going to move this negative 7 over to the other side. It's going to become a positive 7. Alright, so we're mainly concerned right now with this right here. So x squared minus 4x. Okay, so these pieces go inside of this square here. They go on the inside. We're trying to figure out what's going to go on the outside to make that. So the x squared we're going to put here. And because this is a square and it's got to be symmetric in a way, we need to distribute this negative 4x into these two boxes here. So this box and this box. So we need to distribute them evenly. So negative 4x, if we were to distribute that evenly into those two boxes, is going to make negative 2x and negative 2x. So this is giving us critical information for how we complete our square. So the key to this box is that on the outsides here, they have to be the same. And each of those is going to multiply. So like this term will multiply with this term to make x squared. So think of it kind of like a spreadsheet at this point. So what multiplies by itself to make x squared? Well, that's going to be x and x. And what does x multiply to make negative 2x? Well, that's going to be negative 2. And so now that we know this, we know that what number must go there? Well, that's going to be the result of negative 2 multiplying by negative 2, so this will be a positive 4. So we've completed a square, and to complete the square we needed the number 4. Now you notice we started off with the number negative 7, which obviously is not 4. So that's why we had to kind of move it out of the way. So in order to make this square, we have to add 4. It's great. Well, if we add 4 to this side, we have to do it to the other side as well. Okay, so that's what we have. Now, the reason why we're doing that is because now we can kind of go back to our factorization kind of style. We know that this is the same thing as x minus 2 squared, because we've completed a square. And that equals 7 plus 4, which is 11. Okay, so we've done this. Now here comes the part where we go in to solve this. If we have a square, we can undo that by taking a square root. So if we do a square root of x minus 2 squared, we're left with x minus 2. Now, if technically we're left with the absolute value of x minus 2, because the square root of a square is an absolute value. And on the other side, we are left with the square root of 11. Well, the absolute value of anything could either be positive or negative. So what we're going to do, I'm going to slide this over here. So the absolute value of x minus 2, we can now say x minus 2 equals positive or negative square root of 11. Because it could have been, right? Because, if we're taking the absolute value of something, it could be the positive or negative version of itself. So now we add the 2 over, and we get that x is going to be, and I'm going to rearrange this a little bit, I'm going to call it 2, so we move this negative 2 over, 2 plus or minus the square root of 11. Now, you may say, these are really ugly looking. Well, this is one method that can help make things simpler, because you'll see that if we're going to do the same problem another way, and it's a little bit more detailed, but this is a clever method that can give you nice clean numbers if you know how to do it at the right time. The quadratic formula is another way. The quadratic formula says that if we have ax squared plus bx plus c equals 0, then we know that x is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. So if we have the right form, which we do in this case, we can just use this formula and it will help us get the answer. Now, the struggle with the quadratic formula is that it requires a lot of simplification. So we're going to start off and we're going to look over here and we're going to get that x equals negative b. So in this case, b is the number of x's that we have, which is negative 4. So if we're doing negative b, we get the number 4. Now, we then following our formula, plus or minus the square root b squared. So negative. So now we're talking about b now. So b is negative 4. Negative 4 squared makes 16. Then we do minus 4 times a, which in this case, a is the number of x squareds. So we have 1. And then finally c, which is negative 7. Divided by 2a, which is 2 times the number of x squared, so that's going to be 2 times 1, which is 2. So we have it set up. Now we just have to simplify all of this. So we're going to get x equals 4 plus or minus the square root of 16 minus 4 times 1 times negative 7. So if we think of this as a negative 4, times 1 is negative 4, and then negative 4 times negative 7 is a positive 28. And we divide all of this by 2. And we continue with our process. We're going to get x equals 4 over 2. Now you can think of this in 2 separate parts. 4 over 2 is 2. And we have plus or minus the square root of 16 plus 28, that's 44, over 2. So this is actually 2 different parts. Right now we're not, the 2 is not being divided by 2. We've split it up. And so how did we get the 11 previously? Well, if we break this up into x equals 2 plus or minus, right? When we try to simplify a radical, we can look for any squares inside of here, any square numbers that multiply. So when I see 44, I see 4 times 11. So we get, this is the same thing as 4 times 11. Well, the square root of 4 is just 2. Okay, so we get 2 square roots of 11 over 2. And we can eventually just kind of knock out the 2 over 2 because that's redundant, and we're left with the square root of 11. So that is the same answer we got from the previous problem. So you're going to have to excuse my writing. This touchscreen is not as good as the last one that I used to have. So this is the quadratic formula. It'll always give you correct answers, always. So, you know, if in doubt and you have a quadratic equation, use the quadratic formula. Lastly, we've got the graphical method. So, you know, you don't have to solve if you have a graph necessarily. You can kind of pinpoint what the answers are going to be. It's harder when you have decimal approximations, but otherwise, that's what you're going to get. So, in this case, let's say you just wanted to graph it. Now, I'm doing this by hand, but if you had a graphing calculator, or if you had the image displayed as a graph, it's not quite as complicated. So I know, just based off of looking at this graph, that it's got a y-intercept of positive 2. That's here. Sorry. And then I remember from previous problems that my solutions were 1 and 2. So if I make this graph, it's going to look something like that. Pretty poorly drawn, but I'm not an artist. So just by looking at this, I can look down and say, hey, when y is 0, my graph is crossing when x equals 1 and when x equals 2. So I can just automatically say these are my answers just by looking at the graph. Now it doesn't have to cross twice. It could cross once. It could cross 0 times. But it will never, a quadratic equation will never cross more than 2 times. So be advised that there's a bunch of different methods to figuring this out. You can always graph and check it out. You can do it analytically in the 3 ways that I showed. You can complete the square, you can factor, or you can use the quadratic formula. The only one of these that is guaranteed to give you an exact answer every time, easily, what I would say is the quadratic formula. So I'd always suggest working back to that, making sure you know how to use that. But we're going to go into this quite a lot in this unit, but this is just a flashback of things that you've probably learned before that hopefully you can take with you throughout this unit and will give you some help.